All right, let's talk about something that sounds like it's straight out of a sci-fi movie. I'm talking about a technology that can make military stealth, the thing that's defined modern warfare, totally useless. It's called quantum radar.
So just think about that for a second. Imagine a world where the most advanced stealth fighters, the quietest submarines, all designed to be completely invisible, suddenly just pop up on a screen clear as day. This isn't just some crazy hypothetical. It's the exact problem that quantum radar is designed to solve. And if it works, well, it creates a huge strategic shift. A multi-billion-dollar stealth program could be made worthless by a single detection system. And that is why nations around the globe are jumping into a brand new kind of arms race.
So, how is this even possible? Well, conventional radar, the kind we've been using since World War II, is basically a super powerful flashlight. It sends out a big beam of radio waves and then waits for that beam to bounce back. Stealth technology is all about messing with that bounce, either absorbing the waves or deflecting them so the echo is too faint to see. But quantum radar, it's playing a totally different game. It doesn't need a big, loud echo. Instead, it's listening for the absolute tiniest disturbance in its environment, all thanks to the very weird rules of quantum physics.
So yeah, how does it actually work? The science behind this is a real game changer, and it all comes down to this really bizarre phenomenon that even had Albert Einstein scratching his head.
It's called quantum entanglement. Now, this is where things get a little weird, but stick with me. Picture you have two coins that are magically linked. If you flip one and it lands on heads, you instantly know the other one, even if it's miles and miles away, will land on tails. Entangled particles, in this case photons, have a similar connection. Whatever happens to one instantly affects its partner. It's this strange link that scientists first started trying to figure out way back in 1935.
So, a quantum radar system creates these pairs of linked photons. It shoots one of them, we'll call it the Scout, out into the sky, while its twin partner stays safe back at the base. Now, if that Scout photon bumps into anything, even a stealth aircraft, its state changes. And because they're entangled, that change is instantly mirrored in the photon back at the station. It's an incredibly powerful link, but it's also super delicate. We'll get back to that in a bit. By just comparing the two photons, the system can spot a target with mind-blowing sensitivity, cutting through all the background noise that would totally fool a normal radar.
And this isn't just a theory stuck in a lab somewhere. The strategic implications are so huge that major world powers are pouring serious money into this, turning the whole field of quantum tech into a massive international competition. When you look at who's in this race, you see these totally different game plans. On one hand, you've got a nation like China just throwing billions into a huge national effort to dominate quantum research across the board. And then you have countries like Canada being much more surgical about it, with a focused, tactical investment of about $2.7 million for a very specific quantum radar project.
And Canada's goal is super practical. They need to secure their huge Arctic airspace. The idea is to use quantum radar to upgrade their old North warning system, this chain of 54 radar stations, so it can actually detect the next generation of stealth planes and missiles that might try to fly over the polar ice cap.
Meanwhile, you've got researchers in China who've already reported some major progress. They've apparently gotten experimental systems to achieve a detection range of up to 100 kilometers. This is a huge deal, because it shows the technology is moving out of the purely theoretical and into something that could have real-world operational range.
But for maybe one of the most interesting case studies in all of this, we've got to look at India. They have launched a dedicated military quantum mission, and they have a very clear goal in mind: dominating the seas.
And this isn't some far-off plan either. They're on an aggressive timeline. The whole mission gets formally kicked off in early 2026. Right now, they're already designing new quantum-ready warships with the goal of actually testing and integrating these technologies into the fleet in just a few years.
And wow, India's strategy is just comprehensive. It's not about just one gadget. For their frigates, they're developing something called quantum magnetometers. Think of it as an underwater quantum radar designed to find the tiny magnetic disturbances that enemy subs leave behind. For their own submarines, they're working on quantum gravimeters. This allows for ghost navigation by mapping the seafloor with such insane precision that you don't even need GPS anymore. On top of that, you've got unhackable communications and super precise atomic clocks for electronic warfare. It is a total quantum overhaul of their entire navy.
But for all this incredible potential, we're not living in the quantum future just yet. There are still massive scientific and engineering hurdles to get over before this tech can be used everywhere. And this brings us back to that fragility I mentioned earlier. The crucial weak point is that entanglement is like a soap bubble. The slightest little nudge from the outside world, A problem that scientists call decoherence can pop it and break the link between the particles. Figuring out how to maintain that perfect, delicate connection over long distances is the single biggest challenge they're trying to solve. And beyond that, the technology is really hard to scale up to cover large areas, and as you can probably guess, it's incredibly expensive to develop.
But as researchers work on solving these huge problems, it forces all of us to ask a really big question. I mean, the entire idea of stealth, of hiding in plain sight, has shaped military strategy for a century. So what happens if that advantage just vanishes? In a world where nothing can hide, the very meaning of security will have to be completely rewritten.